Yeah, hello everyone. So as I could not come to the university today, I thought that why not to discuss over Zoom, right? So without any delay, let's start the class. I'm going to share the screen. I hope you guys are joining. Okay, so you can see from here. So we discussed about the Bayes parsers last class, right? We have gone through one problem. You can take a screenshot of this also. This we need to perform Bayes parsers for I. Okay. Let me hide this. Okay. To do that, then heap is what? A binary heap is a binary tree with the following property. It is a complete tree. See, you guys should know that means what is tree, what is graph, what is complete tree, right? You have to know. So binary tree is a binary, you know that which has two sides, left and right, right? A binary heap is a binary tree with the properties like it is a complete tree. That means all the levels are completely filled except possibly the last level, and the last level has all keys as left as possible. मतलब लास्ट लेवल हो सकता है खाली हो, बट उसमें भी एक कंडीशन है कि लास्ट लेवल का जितने भी कीज है लेफ्ट साइड से वो फिल होगा, राइट? मतलब लेफ्ट साइड वाला फिल हो सकता है। ऐसा नहीं है कि कंप्लीट ट्री मतलब पूरा ही वो मतलब it means all the nodes are occupied. Maybe the last level is free, but the last level you will see the left side is means tried to fill. Okay. Now a binary heap is a either min heap or max heap. तो बाइनरी हीप मीन हीप भी हो सकता है, मैक्स हीप भी हो सकता है। इन ए मीन बाइनरी हीप द की एट द रूट मस्ट बी मिनिमम अमॉन्ग ऑल कीज प्रेजेंट। मतलब मीन हीप में जो रूट में रहेगा वो सबसे कम होगा, और मैक्स हीप में अपोजिट होगा। क्या होगा? रूट में जो होगा वो मैक्सिमम रहेगा। ठीक है। हाउ इज बाइनरी ट्री इन हीप रिप्रेजेंटेड? So a binary heap is a complete binary tree. A binary heap is typically represented as an array. ठीक है। The root element will be at array 0. AI minus 1 divided by 2 returns the parent node. Then A array 2 cross I plus 1 left side and 2 cross I plus 2 right side. ये याद रख लेना. You can see this is the binary heap, right? So now positions are like this: 0, 1, 2, 3, 4, 5. So how the locations are being kept, you can condition, you can apply the theorem twice I plus 1, twice I plus 2. 2 into I, you can recall here twice I plus 1, twice I plus 2. Twice I plus 1, that is left, twice I plus 2, that is right. So 2 into 0 plus 1, that is 1. 2 into 0 plus 2, that is 2. So this is the side, left side and right side. Similarly, you can calculate these two. Okay? 2 into 1 plus 1, 3. 2 into 1 plus 2, 4. So this is the left and right side. Similarly, 2 into 2 plus 1, that is left side. Now come to the A star search algorithm. Please carefully listen. Maybe noises you can hear. Sorry for that. But you take screenshot also, you will get it. A star search is the most commonly known form of Bayes parser. So मैंने क्या बोला? Bayes parser का एक commonly known algorithm, or you can say extension है A star algorithm. It uses heuristic function Hn and cost to reach uh, the node n from the start state, that is Cn. So Hn use karte hai, it uses heuristic function Hn, and then that is a cost to reach the node n from the start state Gn. Now it has combined features of ECS and greedy Bayes sparse search, by which it solved the problem efficiently. Now, is the algorithm finds the sorted path through the search space using the heuristic function. Same thing. But यहाँ पे जो heuristic function है, that is a bit different from the Bayes sparse search, right? This A-star algorithm expands less search tree and provides optimal result faster. and it uses the function gn plus hn. Remember, it is gn plus hn. पहले हमने gn use किया था, but in the A-star algorithm, it is gn plus hn. ठीक है? So in A-star algorithm, we use search heuristic as well as the cost to reach the node, and hence we can combine both costs as a also known as fitness number. इसको मैं दिखा देता हूं. ये है फंक्शन. ठीक है? इसका एक स्क्रीनशॉट ले लो. तो fn, that is the estimated cost of the cheapest solution, and gn is the cost to reach the node n from the started. Reach node n from the started. Then from the node n to the goal net, that is been given by hn. समझ में आ रहा है? gn क्या है? Cost to reach the node n from the start state, and hn is the cost to reach the goal node from the n. So ये दोनों मिला के जो दिए रहे हैं आपको, that is fn, which is the estimated cost of the cheapest solution. So algorithm. Okay, step 1, place the starting node in the open list, same as it is. You have attended the last lecture, that is the best first search algorithm, right? There we are maintaining two lists, open list and closed list. Here also the same thing. So place the starting node in the open list. This is the step 1. Step 2, check if the open list is empty or not. If the list is empty, then return failure and stops. राइट अगर ओपन लिस्ट में कुछ एलिमेंट्स होगा ही नहीं तो हम क्या करेंगे, हम एक्सप्लोर कर ही नहीं सकता, राइट? सो दिस मीन इट इज फेलर एंड वी हैव टू स्टॉप. देन स्टेप 3, select the node from the open list which has the smallest value of evaluation function g plus a, जिसको हम फिटनेस नंबर भी बोलते हैं. ठीक है? तो क्या कर रहे हैं हम, ओपन लिस्ट में से वो पार्टिकुलर नोड को उठा रहे हैं जिसका क्या वैल्यू, इवैल्यूएशन फंक्शन का वैल्यू सबसे स्मॉल हो, right? If node n is the goal node, then return success and stop. Otherwise, we come to the step 4, expand the node n and generate all of its successors and put n into the closed list. जब हमने n को expand किया, उसको हमने रख दिया closed node में, right? For each successor set, check whether n is already in the open or closed list. If not, then compute evaluation function for n and place into open list. ठीक है? अब हर एक सक्सेसर के लिए हमने चेक किया कि क्या ये ओपन लिस्ट में है या क्लोज लिस्ट में ऑलरेडी है. अगर नहीं है तो हम क्या करेंगे, इवैल्यूएशन फंक्शन को मतलब इवैल्यूएशन फंक्शन के थ्रू उसका वैल्यू निकालेंगे, फिटनेस नंबर, एंड उसको ओपन लिस्ट में रख देंगे. स्टेप 5, एल्स इफ the node n is already in the open or close, then it should be attached to the big pointer which reflects the lowest cn test value. यहाँ पे और एक चीज है कि हम एक रास्ते से जा रहे हैं, दूसरा वाला ज्यादा अच्छा ऑप्शन दे रहा है, then it should reflect the lowest value, right? ये इसके लिए हम बैक पॉइंटर यूज करते हैं. Then step 6 is the return to the step 2. These are the steps. Please remember the steps. I hope everything is clear and write down on your copy. So here we are taking one example. This is the graph, right? Starting S from A, like these are the nodes. Now we will traverse the given graph using A-star algorithm. The heuristic values are given in the table, right? Fn is equal to gn plus hn. Now ये दिया हुआ है S, hn value 5 है, A का 3, V का 4, C का 2, D का 6, Z का 0, right? You can do it by your own, but बहुत सिंपल है, जैसे बेस पर सर्च किया था ऐसे ही. बात यहाँ पे आपको दो वैल्यू कैलकुलेट करना पड़ेगा, gn एंड hn. gn प्लस hn करके fn का वैल्यू कैलकुलेट करना पड़ेगा. इसका सॉल्यूशन कुछ इस टाइप का होगा. टेक इट. ठीक है? इनिशियलाइजेशन हमने किया S5, ऑब्वियसली स्टार्टिंग से हम इनिशियलाइज किया, राइट? और इसका hn वैल्यू दिया हुआ है 5. देन आइटरेशन s goes to A4, s goes to Z10. यही तो था. s से क्या था? s से आपका A था और S से Z था, ये दोनों कनेक्टेड था, पर उसका वैल्यू क्या था? S से A1, S से Z10, राइट? ठीक है? तो ये वैल्यू हमने पुट किया. Now from that, what we have to select? We have to select the one with less. S to A कितना है? 3, S to Z 0. So 3 plus 1, 4, and 10 plus 0, that is 10. SA4, SA0. So we have to explore S to A4 because the value is less. Then A से क्या आ सकता है? A से आपका C है and B है. C का 2 है, B का आपका 4 है, right? So SA to C, that is 4, SA to B, that is 7, right? 4 plus 3, 7. Then got it, 4, right? Then S to Z to already 10 है. So यहाँ से हम क्या उठाएंगे? Obviously S to A to C, not B. Or C, because the left value is 4. So C say, now we have Z that is at 4, that is C is true, right? 2, already it is being given 4. So 2 plus 4, that is 6. Okay, others, no need of exploration, already given the value, we compare it and we got it as 8 C Z. So this is the part as it is giving the less or optimal part with cost 6. I hope it is clear. Okay, those who have not joined yet, they could see the recorded part. Now, points you have to remember, guys. Remember, A-star algorithm is very important in artificial intelligence, right? So, A-star algorithm returns the path which occurred first, and it does not search for all remaining paths. ये एक चीज है जो सबसे पहले अच्छा दे देंगे वही से वो भेज देते हैं वही रिटर्न कर देते हैं सो द एफिशिएंसी ऑफ A-star algorithm depends on the quality of heuristic. ह्यूरिस्टिक फंक्शन को आपने कैसे बनाया है उसके क्वालिटी के ऊपर डिपेंड करेंगे A-star algorithm expands all nodes which satisfy the constitution FN and up complete and optimal detect. A-star algorithm is complete as long as branching factor is finite. अगर branching factor infinite होगा तो ये tree बढ़ते जाएगा infinitely. So it will not be complete and cost at every action is spaced. Then ये दो condition होगा तो we can say that A-star algorithm is complete. Optimal. A-star algorithm is optimal if it follows two conditions. First, admissible. The first condition requires the optimality is that ASIN should be an admissible heuristic for A-star T, and admissible heuristic is optimist in nature. So जो admissible है उसको हम लेंगे and consistency second required condition is consistency. तो optimal कब होगा? दो कंडीशन एक एडमिसिबल जो भी वैल्यू हम ले रहे हैं वो कुछ अनफिजिबल होना नहीं चाहिए वो एडमिसिबल होना चाहिए जो भी वैल्यू वो पुट करके देंगे वो हम उसको लेके चार्ज कर सकते हैं एडमिसिबल होगा कंसिस्टेंसी होगा तभी हम बोलेंगे वो ऑप्टिमल है इफ द ह्यूरिस्टिक फंक्शन इज एडमिसिबल देन ओनली will find the least cost path. ये पूरा मैंने बोल में रखा you can make a note on that because sometimes MCQ comes like this type of question. Thoughts, facts are asked, right? Time complexity, we have to know big of B to the power D, where D is the depth of the solution. So the time complexity of A-star search depends on the heuristic functions and the number of nodes expanded. Okay, so big O of B to the power D. B is the branching vector, D is the depth. Space complexity will be also same, big O of B to the power D. ठीक है एडवांटेजेस क्या है A-star algorithm is the best algorithm than other search algorithm. मैं इसलिए बोलता हूँ बार बार आर्टिफिशियल इंटेलिजेंस में A-star जानना बहुत जरूरी है ठीक है पर A-star जानने से पहले क्या जानना जरूरी होता है यू हैव टू नो बेस्ट फर्स्ट सर्च that we already discussed in the class. Then A-star search algorithm is optimal and complete. वो दो condition मिल हो जाए तो वो optimal ही होगा and complete होगा. And this algorithm can solve very complex problem. Disadvantage is that it does not always produce the shortest path. It's mostly based on the heuristic and approximation. अगर आपका heuristic का quality सही है, then it will give you the best path, shortest path. Otherwise not. So A-star search algorithm has some complexity uses. We go B to the party. अभी हमने देखा था big O B to the party. That may be maybe means maybe more or that be a large value if D is more, right? Also B is more. The A-star algorithm has some complexity issue. You got it. The main drawback of A-star is the memory requirement as it keeps all the generated nodes in the memory. So it is not practical for various large scale problems. Still, despite of these disadvantages, I can see that the A-star algorithm is very important. And I have to say that in the exam also, that's why at least one question is being asked on A-star algorithm. Okay. Then one more extension is the AO star algorithm. AO star algorithm is based on N or graphs or N or trees. ठीक है, मतलब हम क्या करते हैं, प्रॉब्लम को N arcs में ब्रेक करते हैं. One N mark may point to any number of successor nodes, and all this must be solved so that the arc will rise to many arcs, indicating several possible solutions, and the graphs is known as N or instead of N. तो क्या होता है, ग्राफ का दो पार्ट है. N में बहुत सारे ग्राफ हो सकते हैं, तो N का पोर्शन आपको पूरा कैलकुलेट करना ही होगा. और वाला पार्ट ऐसे है, देखो एक मैं एग्जांपल देता हूं. हमें एक टीबी सेट चाहिए. वी वांट टू एक्वायर वन टीबी सेट. देयर आर टू थिंग्स. Either you go to a shop and steal TV set. So TV to চুৰ কৰি আনিলা. You have stolen one TV. That is okay. That is although not okay ethically, but you will get the TV in one part, right? You can say instantly you'll get a TV. You don't need to go explore another things. But there are another way. Earn some money and then buy TV. So, but these two are related. Means they have to. All these two should be done to get this एक्वा टीवी. मीन्स एन आर्क में जो है दोनों से एक साथ करना पड़ेगा. अर्न सम मनी, उसके बाद बाय टीवी. राइट, सिर्फ अर्न सम मनी से नहीं होगा, या तो सिर्फ बाय टीवी आप अकेले नहीं कर सकते हो. तो एन का मतलब है जो भी आर्क है दोनों को साथ में दोनों को करना पड़ेगा. और ग्राफ में जो है वो एक से आपको सोल्यूशन दे सकता है. ये एक बेटर एग्जांपल है एन और आर ग्राफ का. सो एन एल्गोरिथम इज टू फाइंड ए सोल्यूशन इन एन और ग्राफ मस्ट हैंडल एन एरिया appropriately. So A star algorithm cannot search N or graph efficiently. That's why we have another thing that is AO star algorithm. ठीक है, तो ऐसे ही आप इसका भी आप देख सकते हो, एक्सप्लोर कर सकते हो. तो इसमें क्या है आपका, just let me go to the algorithm. C consists only to those nodes representing initial state, that is I and T in it. Okay, we need to calculate its destinies until it is labeled as solved or it becomes greater than futility. We have to repeat, trace the mark arcs from it. Okay, in it, initialize node. Okay, and select an unbounded node. Generate the successor of node. If there are no successor, then we have to assign futility. Futility मतलब एक ऐसा state, उसके बाद हमें नहीं जाना है. फ्यूटिलिटी मतलब हमने पीक पहुंच गए, या तो उसको सक्सेसर जनरेट नहीं कर सकते, या तो उसका वैल्यू ऐसा एक वैल्यू है जो हम अवॉइड करेंगे. ठीक है, assign futility to edge this node. This means that node is not solvable. If there are successors, then for each one called successor that is not also an ancestor of node, you have to do the following: add successor to the graph. If successor is a terminal node, mark it short and assign 0 to its edge value. If successor is not a terminal node, compute its edge value. Propagate the newly discovered information up to the graph by doing let S be a set of nodes that have been marked solved. Initialize S to node until S is empty. We have to repeat. Select a node from S. We call it current and remove it from S. Compute age dash. Okay, we the age dash of each of the arcs emerging from current, and we assign minimum age dash to current. Mark the minimum cost path to the base out of the current. Mark current solved if all the nodes are connected to it through new mark and have been labeled solved. If current has been marked solved or it has age dash value that just changed, its now new status must be propagated backward up the graph, hence all the ancestors of current are level. तो मतलब क्या है यहाँ पे एन और ग्राफ नाम से ही समझ में आ रहा है, या तो आप इस साइड जाओ या तो इस साइड जाओ. तो आप मतलब देखो, आप सक्सेसर जनरेट कर रहे हो, सक्सेसर में ऐसा एक नोड मिल गया जिससे आप देख सकते हो कि आपको और ऑप्टिमल सॉल्यूशन और बेटर सॉल्यूशन मिल सकते हैं, तो आप उसमें चले जाओगे. ठीक है, उसका वो रूट को ले लोगे. पहले ऐसा नहीं था, पहले जो नोड मिल गया, पहले सॉल्यूशन मिल गया, वही ले लेते थे. बट एन और ग्राफ में हम सारे पॉसिबल पाथ को एक्सप्लोर करते हैं. ठीक है, सो प्लीज टेक ए स्क्रीनशॉट ऑफ दिस टू एल्गोरिथम, राइट इट ऑन द कॉपी. इफ यू डोंट गेट एनी पॉइंट, यू कैन आस्क मी डायरेक्टली. ठीक है, so with this I want to end this class. There is a simple assignment for you. So from this lecture you write these two algorithms, A star algorithm and AO star algorithm, with the numerical example that I have discussed, right? And try to find out the advantages and disadvantages of both of this A star and AO star algorithm only from the notes that I shown you for this class. I hope it is okay. Thank you very much.